Welcome. On this channel, I do unscripted, unedited videos of Linux programming and stuff. Most recently, I've been working on relearning C. It's been about 25 years since I've used it. Really just kind of getting into that right now. And in the most recent previous videos, I have been working on just getting reacquainted with basic operations like file operations and malloc and things like that. Two videos ago, I ran into a problem where I was clearly not understanding the syntax around pointers to pointers and allocating some memory in a function. I then jumped over and then reaffirmed that, well, I actually do know the syntax. I suspect what I was getting wrong was something about, clearly I was still getting something wrong. It wasn't working. I suspect it's in the fact that I was referencing a local variable instead of the referred to pointer. We'll see. Today, I'm going to dive back into that and see if I can sort it out. Just be a little more meticulous in debugging the problem. That will be the first thing that I do. So, like always, I am going to create a video or a folder for today's video. It is going to be 020. I think I'll just call it debug pointer. That is kind of a pointer to a pointer. That's kind of the problem I have at the moment. I think I'm going to clean this up a bit in that I know that the unified I won't do it right now. I was going to clean it up so that that I really only have these video the folders corresponding to the videos here, but some of these actually do correspond to videos. They're just unnumbered. Both the demo and the unified demo I do know correspond to previous projects. The Hello World is and the images one do not, but I will clean those up later. Okay, back to what I was going to do, which is drop into 020 here, and we can take a look at oh crap, I don't want to copy 020. I want to copy 19. Or 18, I mean. That was where I actually had the problem, and then in 19 is where I was verifying that I understood the syntax correctly. So this one will be 020 debug pointer to pointer. Okay. And roughly, I'll try and hit on the problem here. So I have a buffer pointer that here. Okay, so I moved a bunch of functionality out of main into this load file. So my intention was to load and free file, and then so here I'm iterating over the arguments passed to the application. For each of those, I am calling load file and hoping to get back just that buffer that I then later free when I'm done with it. And then everything else, is moved up into those functions. But I pass my goal here is to update this pointer to be the allocated buffer. And so I'm going to get super meticulous about this. It's going to be, a little on the tedious side, but if I print f and I say the the buffer pointer nope, that is not what I wanted, is going to be some address. So I want to do two things here. So the buffer pointer is going to be just buffer. That is the value of the buffer. And then I want the address of the buffer as well. I want to look at these. Like I said, I'm going to be super meticulous. And then for the time being, I am going to just call exit. That's fine. Build that. Okay, what did I break? Line 52. No semicolons. Wow, really messed that up. I never completed it. Okay, so we have buffer 0, and then the address is that thing. So that works, right? And what I should be passing here is that second value. Let's actually demonstrate that we can write into. So let's make given the buffer pointer well, let's just do and then do these again, right? Again, I'm just being stupid in how meticulous I'm going to be about this. But we can see that we actually did change the value. Let's improve our output here. So, oops. Why do I get that? Interesting. So there we are. Okay. Now let's not stop there. We're gonna jump into this function, and I do believe that my problem is right here. So let me see if that runs to completion without failure. It does, but if I put it here, okay, that confused me. So let's now here you'll notice that buffer is a pointer to a pointer. Let's start by stealing these. And we're going to do this before and after. So we have let's start with this one. So just buffer. Like I said, we're going to do it before and after. And the value of buffer changed. But what I think I wanted to do was to change what it points at. And so buffer itself doesn't change. That's, I believe, what I want. But let's take a look at what it's pointing at. And it was that value I set before, and now it's this new value. Now, I believe that after I return from here, load file that, let's take a look at the values for buffer. And let's put the exit here. Not here. And we've already blown up in the free. But why was free called? So if there was an error, we should have... Okay, so we allocated into star buffer. We should have freed star buffer, right? Well, we have a segmentation fault. fread failed. So we didn't end up in the malloc failed. Oh, we need to read into the buffer. There we go. I actually think that was the fix, right? I think all this time I was not reading into so some of this was me narrowing back into where I started out. I originally did have the malloc going into star buffer. I believe that the fread was not going into star buffer, and that was my problem. So I think I just found the problem. What I will do here is just comment that out and see if it runs to completion, and it does. Yep, that was the problem. So again, probably a combination of me. I didn't conceptually misunderstand it at any point. I just was fumbling around with, you know, I had missed the star buffer here, and then not being so familiar and comfortable with it, and I actually did have the free of the star buffer wrong also, and then the combination of me, you know, basically not getting it right the first time, kind of typoing it, and me not being super familiar with working with this anymore. I just oops, missed that as I was trying to debug it the first time. I knew I couldn't be too far off because when I went to do the experimentation in the previous video, I kind of proved to myself that I understood the syntax. Okay, so let's, did I get it all? I think I did. So at this point, the idea here is that I moved up all of the I'm going to call that good, but I'm going to add one little, I think, yeah, I'll call that good. That was the intention for this video, was to identify this stuff. I'll walk through it here just briefly. So main, it iterates over all of the command line arguments, ignoring the first because that is just the application that is being executed. We load file. Well, let's go back down here. We load file and we eventually free the file. The only thing we do once we have the file's contents, the buffer, is we just iterate through it, outputting every character, which is 4K characters, one at a time there. Pretty dumb program. Okay, load file is being passed the path and the buffer that it's eventually going to put stuff in. We open that file. If we succeed, no problem. If not, we give the error message and we return -1. When we return -1, we do not pass here, right? So we just go to the next, we just skip to the next command line argument. Assuming we didn't fail to open the file, the next thing we're going to do is we're going to call stat on the file so that we can get its size. If we fail to do this, we just close the file that we have open, and the same thing happens. We'll continue through the loop to the next argument. Assuming we managed to stat the file, we needed its size so we could malloc that space. We actually do malloc a buffer of that size. If the malloc doesn't fail, or no, let's do it fails. If the malloc fails, we again just close the file and then continue through our loop down below. If we did malloc the buffer, then we read the contents of the file into that buffer. Assuming that the read succeeds, we just move on. If the read fails, we output a message. Now we have to free the buffer and then close the file, and again we'll fall down and it'll continue on to the next argument in the list. Assuming that all of this succeeded, we close the file. It does not need to be open anymore. We do not free the buffer, of course, because we're going to use it, and then we free it here. And then we return the actual number of bytes read. So that is the format here, right? It copies the fread in the sense that if bytes read is 0, it always returns the number of bytes read, 0 or more. If it is 0, it's either because no bytes are read or there was an error, and we continue. If you did want to know the error down below, you would have to go through the same. P error would still contain it, and you would reference what the error was there, but we've already output the error too. Okay, so then we just iterate through all the bytes. Then we free the file, which is, again, just, which is, I'm wondering, I'm doubting suddenly whether this free is right. So normally you would just, it should be good because it's the same value. Yeah, it should be fine. The value we need to free, oh no, is this pointer. Yes, it is freed. Okay, so that is the entire program. That solves that problem. And I will see you in the next video.